time. If we could make this one go faster, like 10 times faster, our program would run a lot faster. We did a lot of physical I/O, and we know from experience that physical I/O can be slow. We did a lot of logical I/O, and this is one that confuses some people. Logical I/O reads from memory is very expensive. An experienced person who knows Oracle inside and out knows that logical I/O consumes lots of CPU cycles. It takes thousands of CPU cycles in order to go and get a block out of the buffer cache. It's not free. Once we realize that, we're on our way to tuning this again as well. There's a big difference between the elapsed time and the CPU time. Whenever you see that, you know for a fact that you were waiting for something. If it took 3 minutes to run, but only 90 seconds of CPU time, now if it only takes 90 seconds of CPU time, if I didn't have to wait for anything, I should be able to finish the query in 90 seconds. But if it took 3 minutes to run, I must have spent a long time, 90 seconds, waiting for something. We can see the query in our plan, and we know the answer to our query. We can take this and start deriving other facts. A lot of people would stop with this list and start trying to tune. You need to go one step further and build out that context, that set of information a little bit further. And the reason you can do this is twofold. One, you know the data. Hopefully you know the data. The person who is best situated to tune a query is the person who knows the schema. I know how the tables relate to each other. I understand the relationships. I know the size of these tables. I know how the data is organized. Tuning a query without that information is very difficult. So the person doing the tuning, hopefully they know the data. And they know how Oracle works. They understand the difference between full scans and index range scans and so on. They know how the database fundamentally works. So they can take this information and, given this background, add some things. The first one was we needed a very small subset of the rows, about 700,000 out of 128 million. How did I know that? Well, we go back to that TK Prof report, and I can see down here in the middle of the page that we read 128 million rows out of the table. We were counting interesting rows, and that count was 700,000. So apparently, we only needed 700,000 out of 128 million of the records. 700,000 sounds like a big number, doesn't it? I mean, 700,000 is huge. Not when you compare it to 128 million. That's less than 1% of the information in there. Less than 1%. Even though that's big, 700,000, maybe an index is going to figure in here somehow. Let's file that away in our head. The second observation I was able to make was the table looks well packed. And when I originally wrote this on Ask Tom, all I wrote was the table looks very well packed, dense. We don't need to reorganize this. It's not a problem with having lots of wasted space out there that we're processing. The table is as compact as possible. And somebody came back immediately after I wrote that and said, "How did you know that?" And I had to come back and qualify that and said, "I know my data, and I forgot to tell you how well I know my data. I know that the average row width of this table is about 125 bytes. I know that because it's my table, and I know that I get about 70 to 75 rows per block. If you do the math, how many IOs did we do against that table in the full scan? 1.8 million. Divide that into 128 million. We're getting about 70 rows per block. If I was to reorganize that table, just rebuild it, it wouldn't make the data any faster to query. I'd end up with exactly what I had in the first place. So you're able to derive lots of extra facts, build more context. Now we know Oracle. Now we apply that knowledge to all of the facts we have. What could we do here? We could make the full scan faster. How could we do that? Well, I know that since Oracle 9i Release 2, if I rebuilt the table with an alter table T move, I could also say alter table T move compress. I might be able to make this table take half the space. That might make the full scan go twice as fast. Maybe I understand how indexing works. Maybe if I include sub-object name in some index to avoid the table, we could use the index to answer this query. Because if I go back to this TK prof, I can see that we did a full scan of the table, but we were counting sub-object name. We were counting how many non-null occurrences of sub-object name there were in this table. There were only 700,000 out of 128 million. If I was to add sub-object name to some index, I would be able to fast full scan that index to count those occurrences. And now the table has lots of columns and is very wide, but I could create the index on a subset of columns and it would be smaller. That would be a way to make the full scan faster. Full scan an index instead of the table. Another way would be remove the full scan. The fastest way to do something is not to do it in the first place. We're only interested in 0.6% of the data when you actually do the division. Maybe a new index that doesn't exist. Don't add sub-object name to some existing index. Just create an index on sub-object name. If you know Oracle indexing, you know that Oracle only indexes keys that have at least one not null value in it. So if I took this 128 million row table that has 700,000 rows that are interesting, and I created an index on that column, the index would only have 700,000 entries in it. It wouldn't have the 127 million other ones because those values were all null. So this index would not only be very skinny, very narrow, it would also be very short. It would only be indexing the data of interest. This is probably the best answer for this particular query if I really needed to know this count. Because the last one down there is don't do it or do it differently. What is the fastest way to do anything? The fastest way to do anything is to not do it in the first place. You can't get any faster than that. That always takes 0 seconds. I didn't do it. It went infinitely fast. When I see queries that just do counts, select count this from table where clause, I immediately want to look at the code because I bet the code looks like select count. If count is greater than 0, then do something. And I immediately want to say, why don't you just do something? Just call your do something routine. Don't count to see if you have something to do. Just try to do it. I'm like, oh no, that won't work. We need to know that there's data to process. It says, does your routine that does something, does it have the ability to exit out of its loop when it's finished processing? Yes. Well then what would happen if there was nothing to process? It would exit out of the loop immediately. Exactly. We don't need to count and then process. Because the other funny thing is, in between the time you count and in between the time you process, the count might change. You might find that there's 10 rows to process, but by the time you call your do something routine, somebody else has already done that, and there aren't 10 rows to process anymore. Or another common one I hear is, we have to count the rows because the report starts with, we're going to do 10 things, and then we do them. I say, well, you do understand that between the time that you count and you process, that might change. You might print on the report, we're going to do 10 things, and then only do 9. Or you might print on there, we're going to do 10 things, and then do 11, because a new one was added. I said, just do the processing, and at the bottom of the report, tell them how many you actually did.